in the first homework set for the special methods. In the first one, I would like you to develop a fraction class. Mainly, I would like you to support only the following functionality. You don't need to go beyond that. We're just stressing your ability to implement some of the special methods. The init function here is receiving a fraction of integers only. Integers. Feel free to go deeper. Feel free to implement more methods. You are actually highly encouraged to that. But my given code is mainly supporting these simple instructions. Note that when we have a fraction here 4/8, then this can be simplified to half. To do the simplification mathematically, you need to compute the GCD. If you don't know the GCD or don't remember at all, it's good to refresh, but you feel free to skip it. The core functionality given here is mainly the multiplication, either a small factor or a fraction, and some comparison between the items. The f1.value is actually computing the actual fraction value. So if the fraction value is half, it's going to print 0.5, and so on. In the second problem, we would like to implement a vector class. A vector is just like in math, you have a bunch of numbers representing some vector in geometry. And here we have two vectors, v1 and v2. As you see, we are flexible in passing the numbers. And v1 plus v2 is this number, 5 for 1, 5, 2, 5 is 7, 3, 1 is 4, 4 minus 2 is 2. And also you are supporting comparisons. Again, feel free to go deeper, but you only need to implement something that matches the following. If it happens that I'm asking you to add two vectors that are of different length, then you have to raise an error. You don't need to go more than that. You can assume that there is no intentional mistakes from the user. However, in practice, this happens. I'm just trying to keep things simple in these assignments. The third one is a bit an interesting case. We referred to that before. Let's say we created f1 as 1 plus 3/7 minus 1. The value of that is clearly 3/7. And f2 here is directly 3/7. If you try to print f1 equal f2, the answer will be false, and this will be a big surprise. Printing the values of f1 and f2, you will notice they share several digits here, but they don't end equal here. And that's why in comparison it doesn't work. We once said that the representation of float is an approximate representation. This is intended. And this means we shouldn't compare floats directly. It will not work. There are several Python ways to do that. But for now, I would like to keep things simple. I would like you to create a class myFloat that is acting almost as a float class, but the class can be used for the comparison. So if now I'm comparing f1 and f2, they are going to be true. Mathematically, one way to compare two float values is as following. The core case, the challenging is to compare for the equality. To know if two numbers are equal or not, you mainly need to check the difference between them. So if you computed the absolute of the two numbers like f1 and f2, if this absolute value is very, very, very small, let's say 0.0000001, something like that's very small. If the gap is very small, we know that they are almost equal. There is typically a challenge like what is the good value to make it like the comparison, like what is this very small value to compare with it. This is an issue. I would like to tell you something, but do not confuse yourself with it. Due to the equality issues here with the floats, we cannot use the floats with dictionary as keys. This is very wrong. It will not work because the keys aren't approximate. However, with our solution also, we still cannot use dictionary. In C++ it will be possible, but in Python it will not be. Why? Because again, we need to provide like a way to handle the hashing issues in the direct comparison here. So still we cannot use it with dictionary either before or after, but at least now we can make these comparisons in a valid way. That's all.